All right, this is Geometry 2.1, Monitoring Progress, numbers 10 to 13. This section is all about definitions. Now, in mathematics, a definition is kind of a two-way statement. Here, for example, it says, if an angle is a right angle, then its measure is 90 degrees. So, if this statement's true, and I show you an angle and I say, hey, it's a right angle, then you could make the following conclusion: it measures 90 degrees. But in mathematics, a definition also goes the other way around. And if you showed me an angle and said, hey, this angle is 90 degrees, I could conclude that it's a right angle. So this statement would have to also go the other way and say, if an angle measures 90 degrees, then it is a right angle. So this definition has two parts. First, if it's a right angle, then it measures 90 degrees. And the other part is, if an angle measures 90 degrees, then it is a right angle. So notice that if this is the original conditional statement, this is its converse. I don't like that pointer as well. Now, when both these things are true, we call it a definition, or it's also a biconditional statement. And there's actually kind of a shorthand way of writing it, which goes like this. I'll move this up a little bit. We would say an angle measures 90 degrees if and only if it is a right angle. Now, trying to unpack exactly what this if and only if means can be a little tricky, but if you just remember that it means that this conditional statement is true both ways. So we would say an angle measures 90 degrees if it's a right angle, and it's a right angle if it measures 90 degrees. So if you're given any one part of this, you can automatically conclude that the other part is true. So if I say, hey, I've got an angle that measures 90 degrees, you can say, oh, it must be a right angle. And if I say, hey, I've got a right angle, you can conclude, ooh, it must measure 90 degrees. Because the implication, or the if-then part of it, goes both ways. Let's look at another example. Here we have, let's see, if two line segments have the same length, then they are congruent. So the definition of congruent line segments is that they have the same length. And so this is true both ways. So if two line segments have the same length, then they are congruent. But it could also go the other way. If two segments are congruent, then they are the same length. And again, we can put these together into a single statement. It's a little shorthand here, and we would say two segments are congruent if, and by the way, you can actually even shorten the phrase if and only if to just the single word if with two F's. That means if and only if in mathematics. If and only if they have the same length. So again, This means that if you give me two segments and you say, hey, these two segments are congruent, I can conclude that they have the same length. Or, on the other hand, if you give me two segments and say, hey, these two segments are the same length, then I can conclude that they are congruent. That's what it means for two segments to be congruent. So anyway, so this implication, this if-then, goes both directions. And we say two segments are congruent if and only if, and you could just write that as IFF, they have the same length. Okay, let's look at another one. Now in this one, they went ahead and gave us both parts. It says, if Mary is in theater class, then she will be in the fall play. On the other hand, if Mary is in the fall play, then she is in theater class. Now, if both these things are true, then we can shorten them up and simply write Mary is in the fall play if and only if she is in theater class. So this thing again goes both ways. It's like saying if Mary is in the fall play, then she is in theater class. And at the same time, if she is in theater class, then Mary is in the fall play. And again, it allows us to conclude that one is true from the other. So if I said, hey, Mary is in the fall play, and we assume this statement is true, then you could conclude that she is in theater class. On the other hand, if we assume that the statement is true, and you told me, hey, Mary is in theater class, I could assume that Mary is in the fall play. Goes both ways. And by the way, when you're writing your if and only if, it doesn't matter which order you put them in. So I could say, I could have said, if Mary is in the fall play, then she is in theater class. Or I'm sorry, I could have said, Mary is in the fall play if and only if she is in theater class. Or I could do it the other way around. I could have written, she is in theater class if and only if Mary is in the fall play. It doesn't matter what order we go in. All right, next. All right, we've got, if you can run for president, then you are at least 35 years old. If you are at least 35 years old, then you can run for president. So we're going to go ahead and rewrite this. The two parts of the statement are running for president and being 35 years old. So we're going to say, if you can, oops, that shouldn't be there, not if, you can run for president if and only if you are at least 35 years old. So again, the statement goes both ways. If you say to me, hey, so-and-so can run for president, you can then assume that that person is at least 35 years old. On the other hand, if you say to me, hey, so-and-so is at least 35 years old, then I can conclude that that person can run for president. Not necessarily that they would, though. All right. So again, biconditional statements. If you have a statement, I'll scroll this down a little bit. So again, if you have a statement, and it's a conditional statement, and it's converse, and they're both true. So if it's true, if you can run for president, then you are at least 35 years old. And if it's also true that if you are at least 35 years old, then you can run for president. If both those things are true, you can rewrite them as this biconditional statement. You can run for president if and only if you are at least 35 years old. And again, you could just switch the order around too. You could have started with, you are at least 35 years old if and only if you can run for president. All right.